Good morning. Today we want to look at simplification of algebraic expressions. But before we do that, we want to look at the way we can operate on algebraic operating signs, that is addition, subtraction, multiplication, and division. So when we look at the operation of the signs, we have to appreciate that positive, when we have a positive number, you add it to another positive number, the results you get will be positive. What is circled here means we are adding a positive number, and this is the operating sign. This is another positive number, and we are adding, the operation is addition, so the result is a positive number. And we have given an example on the same. If we have 2x, where 2 is the coefficient of x, then you add to 3x, where 3 is another coefficient of x. Now, you can see, we can see that x is here and x is there. So it is a common factor in the two factor terms. The first term, x is common. The second term also, x is common. And because it is common, we can filter it out and then add the coefficients first. And remember, in our previous lessons, we have said that a number multiplied by a pronumeral gives us what we call an algebraic term. So when we add 2 plus 3, we obtain 5. But that 5 now is the coefficient of our pronumeral x. So the result will be 5x. And we have carefully placed x on the right-hand side so that we don't confuse when we are multiplying to write, like if I had x into 2 plus 3, we can easily confuse and write this one as x5. So we put x at the extreme end so that when we open the bracket, we read it as 5x. That's why I've carefully put the pronumeral at the farthest end. So you add the coefficients, then you multiply by the pronumeral, you multiply by the pronumeral, you multiply by the pronumeral to obtain 5x. That is part one. So any positive number added to a positive number, the answer we get is a positive. And we have seen one example like that. The second one is positive number plus a negative number. A positive number plus a negative number. The answer will either be positive or negative. And here we have carefully said positive or negative depending on the numerical face value of the coefficients. Remember yesterday we talked about when I have a need, I need some, let's say, money to purchase an item. But what I have is less than the value of what I want to purchase. So what I lack is what we call my need. It's a deficit. So if I have, let's say, $20. And this is what I have. And I need $80. I have $20, but I need $80 to satisfy my want. Now, because I have 20 and I need 80, it means that my deficit will be $20 minus $80. And that will give you, because it is what I have is far much less than what I need. The difference between 20 and 80 will be my deficit, and it is treated as a negative. So this will be negative $60. So you can see there that when I can write this one as, we can also write this one as $20 plus minus $80. $20 plus minus $80. I'm basically adding a positive plus a negative. And when I add a positive plus a negative, the answer I'll get will either be positive or negative. In this case, the negative face value of our numeral is greater than the positive face value of our numeral. So here we shall have negative $60. So this is my deficit. So the deficit here is explained in terms of what you require, what you need, but you don't have. Like I need to purchase a shirt. I have $20. The shirt is costing $80. So I will need $60 more. So that need is the one we call negative, because we have to look for it. We have to look for it, either we borrow so that we satisfy our want. So that need is what we call a deficit or a negative number. Next, now we look at an example where a positive added to a negative, the answer will be a positive. And in our first case, we have seen that 5y minus 2y, 5y minus 2y, we follow the same procedure because y is common in each term here. The first term, it is common. In the first term, it is there. So because it is common, we can filter it out. Then we subtract the coefficients. When we subtract the coefficients, we get 3y, because 5 minus 2 is 3. Then we multiply by y, we get 3y. So this is a case where the positive part is greater than the negative part. When the positive part is greater than the negative part, the answer is positive. Now, let's look at the second case where positive plus negative, the answer is negative. We have this example here, 7r minus 11r. Because r is common also in term number 1, r is there, and term number 2, r is also existing. So we can filter out r to remain with what is in the bracket, 7 minus 11. But remember, we have said that if this one face value is less than this one in the face value, then we have a deficit. And 7 minus 11r, the deficit will be negative 4. So we multiply by r to get negative 4r. Part 3, we have negative plus negative. We have negative plus negative. I want to explain this in this way. You want to purchase 2 items. You need to purchase 2 items. Need to purchase 2 items. The first item, a pencil. Second item, an exercise book. Now, these are the items that you require for a particular assignment that you are given. Assume that a pencil cost $1. An exercise book cost, let's say, $2. These are 2 items that you need to purchase. But you realize that you don't have this money in your pocket at the moment. So you now do what we call purchase on credit. You now do what is called purchase on credit. You now purchase on credit the 2 items because you don't have money, liquid money, in your pocket at the moment. So you do what is called purchase on credit. When you purchase on credit, we treat it as negative $1. Now you are purchasing on credit. It is negative $1 plus negative $2. You are now purchasing on credit, and therefore you will have negative $1. That's the credit part, because this is, you are not paying immediately. So it will be treated as a negative, and the other one also will be treated as a negative. So in total, you will be required to pay the vendor. You will be required to pay the vendor later on a total of negative $3. That is what you will pay the vendor later on. That's why now we are saying that you add a negative plus a negative, the result is a negative. That is how we interpret this, that negative plus negative, the answer is negative. So an example on the same is that we have negative 2t This one minus means we are adding another negative. So because t is common, we filter it out and add the coefficients, and our coefficients here are negative numbers. We have -2, -3, -2, -3, we get -5. Then we multiply -5 by t, we get -5t. That is the qualification of negative plus negative. The answer is negative. That is in case of addition and subtraction. In case of addition and subtraction, that is what we have. Now let's look at now the operation on algebra by way of multiplication. Here we have positive times positive. The result we get is positive. And we have given an example here. Positive 2t multiplied by positive 3t. Now when it comes to multiplication, we multiply everything in the operation. And we carefully do that by way of looking at the related items. For example, we have here the coefficient of t as 2. 2 is the coefficient of t here. And 3 is the coefficient of t. So when it comes to multiplication, we multiply each component. Like we multiply 2 by 3. So we multiply 2 by 3. We multiply 2 by 3. When we multiply 2 by 3, we obtain 6. Once we multiply 2 by 3, we again multiply t by t. We multiply t by t to obtain t multiplied by t means it is t squared. But because the whole thing is a bracket, the product becomes 6t squared. So in multiplication, we carefully multiply. If it is algebra, we multiply the coefficients alone, and then we come and multiply the pronumerals. We multiply the coefficients and then we multiply the pronumerals. Then we get what we call a combined product of coefficient multiplied by the product of the pronumeral. That is how we multiply algebraic terms. Let's look at another example on the same. 2r multiplied by 7n. 2r multiplied by 7n here means we first of all multiply the coefficients. So we multiply 2 by 7 to give us 14. Then we multiply the pronumerals also. We multiply the pronumerals. And when we multiply r by n or n by r, we obtain Rn. So you can see that we have multiplied the coefficients first to get 14, and then multiply the pronumerals to get Rn. That is how we multiply our algebraic expressions. So that's it, why we have now here as an example that 2t multiplied by 3t, we are getting 6t squared. Now, the second part is a positive multiplied by a negative. The answer is a negative. And from the example, we have positive 10r multiplied by negative 2r. The result here is negative 20r squared. Let's see how that one has been obtained. We have positive 10 we have positive 10 multiplied by negative 2r. So we follow the same procedure as we have explained in the first two cases. Multiply the coefficients first. We multiply 10 by negative 2. And remember, we have said a positive times a negative, the answer is a negative. So, because we have positive 10 multiplied by negative 2, we have the results as negative 20. Then we have the pronumerals multiplied, that is r times r, which we obtain as r squared. So positive times negative therefore becomes a negative. So the final answer is a negative. We have here negative times negative, and we have said the answer is positive. Likewise here, we do this. We have negative 2 multiplied by r, and we have negative 3 multiplied by r. Now you can see that carefully we have put the coefficients in the negative coefficients in a bracket. So we multiply the coefficients. We multiply the coefficients. This is negative 2 multiplied by negative 3. And because the result is positive, we get positive 6. Then this is positive r now, and this is positive r. Let's multiply the two pronumerals. We multiply r by r to give us r squared. So you can see that negative 2r times negative 3r, the results will be positive 6r squared. When we come to division, we have positive divided by positive. The result is positive. And from the example we have given, we have 8n divided by 2n. We divide each part the way we have done with the multiplication. We follow the same procedure as we are in the multiplication. We divide the coefficients and we also divide the pronumerals. Then we combine. The quotient will be a positive. So here we get the highest common factor between n and n is n itself. So n divides n1 and n divides n once. Similarly, we have the highest common factor between 8 and 2 is 2. So 2 divides 2 here 1, and 2 divides 2 for 8 4 times. So we get 4 times 1 all over 1 times 1. So we get the result as positive 4. That is positive divided by positive. Let's look at positive divided by negative. So here we have positive divided by negative. The answer is negative. In this case, we follow the same procedure and write this one as (6r) divided by 3n. Same procedure followed here is we divide the coefficients and also divide the pronumerals. So we start by saying the highest common factor between 3 and 6 and 3 is 3 itself. And for that reason, 3 divides itself once and 3 divides 6 twice. So on the numerator we have 2, but if we look at the pronumerals, there is no highest common factor between r and n. So it will be left the same way. So here we shall have 2r and the lower part we shall write as n. That is the result. But because it was a negative, we write it as negative that. Negative 2r over n, because we are saying that 6r divided by negative 3n, the answer should be negative. So it will be negative 2r over n. So positive divided by negative, the answer is negative. Likewise, negative divided by positive, the result will still be negative. Let's look at an example on that. We have 12m divided by 3p minus 12m divided by 3p. Follow the same procedure. Minus 12m divided by 3p. So as the rule, we first of all divide the coefficients of the numerator and the denominator. The highest common factor between negative 12 and 3 is 3 itself. So 3 divides here 1, and 3 divides here negative 4. Since there is no common factor between m and p, there is no highest common factor between m and p, we leave it the same way. So the result here we obtain as negative 4m all over p. So you can appreciate that still negative divided by positive, the result will be negative. Finally, negative divided by negative, the result will be positive. Let's look at an example on that. When we have a negative number divided by a negative number, the result we get is a positive. So let's look at that. We have minus 20d divided by minus 4f. We follow the same procedure. We write it as minus 20d all over minus 4f. And because we have a negative divided by a negative, the highest common factor between 20, negative 20 and negative 4 is negative 4 itself. So divide negative 4 by negative 4, you get 1. Divide negative 20 by negative 4, you get 5. Since there is no common factor between d and f for the pronumerals, we remain with 5d all over f as our answer. So we appreciate that negative divided by negative, the answer is positive. So with that now, we are now ready. We have now developed a roadmap for algebraic simplification, because once we have understood how to operate on our algebraic signs, then we can now be able to simplify any form of algebraic expression. Let's look at examples on the same. Let's look at examples on the same. So that is our example, which we want to simplify using the basic concepts we have learned this morning. So the first thing that you do is to, for this particular kind of expression, you first of all group terms with the same pronumeral together. And then you also, like here, we have the pronumeral x and the pronumeral x. So x, terms containing x will be put together. And then we have the pronumeral y and the pronumeral y there. Also terms containing the pronumeral y will be grouped together. So we can write this one as 2x minus 5y, because we have x and x, plus 3y plus 2y. And once we have that, we are now able to simplify this. You can see now here we are using the basic operators we have learned. So I'll simplify this one independently. I simplify this independently, then we add. So let's start with 2x minus 5y. Following the same basic procedures, I'll have 2 minus 5, then multiply by x, But remember, this is positive plus negative. Because this negative, the face value is greater than the positive value, the result here will be negative. So here we get negative 3x. So for this part here, we have negative 3x. Then for this part here, we have 3 plus 2, we multiply by y. So 3 plus 2, the result will be 5y. So our algebraic expression simplify itself to be negative 3x plus 5y. That is the most simplified form of this expression that we can write from that. Let's look at another example. So in this case, we have a complex algebraic expression. So we must follow the procedures that we have learned to simplify this. First of all, here we also apply the rule of BODMAS. Like now here we have division, and here we have multiplication. So we have to divide first. So I'll operate on this one first, then come and operate on that. We follow BODMAS, and finally we add. So we have 4r divided by 2, which we can write as 4r all over 2. This is a term, algebraic term divided by a constant, because here 2 has got no r, so it is a constant. So the highest common factor between 4 and 2 is 2 itself. So we divide by 2, we get 1, and by 2 we get 2. So we get 2r. That is that part. So we have simplified that part. Then we come to this part here, which is 2t times 2. And remember what we said? We multiply constants, the coefficient of t and the constant, because the constant has got no pronumeral t. So we'll just multiply that. We get 4. But t is not multiplied by any other pronumeral, so it remains to be t. So we can now see that we have simplified this and we have simplified that. So we can therefore come and write this one as minus 7r. And remember, we must collect the like terms. The result for this was 2r. And the results for this is 4t. So we write it as plus 4t plus 2r plus r. That is the simplification we have obtained from the expression. So we can further simplify this and write it in the following way. We put all the terms containing pronumeral r together and terms containing the pronumeral t also together. So we write this one as minus 7r plus 2r plus r plus 4t. So once we have done that, now we can be able now to add and subtract all the terms in pronumeral r, which will give us minus 7 plus 2 plus 1. We multiply by r. Why? We filter r out because it is common in each of the first three terms. It is common in minus 7r, it is there in 2r, and it is there in r. So we filter it out. So whatever we remain within the bracket are coefficients. So we add the positives and negatives together to get the results. This is negative 7, this is positive 2, this is positive 1. So we get minus 7 plus 3. I need 7, but what I have is 3. So what I need is far much less than what I have. So that means I still have what we call a deficit, and that will be negative 4r. So once we get that, we have 4t. So we can come and write this one as minus 4r plus 4t. But remember, we must filter out what is common. Minus 4r plus 4t can also be written as 4t minus 4r. But because the pronumerals are not similar, we cannot further simplify this. But because the coefficients of the pronumerals is the same, it is 4 here and it is 4 there, we are allowed to filter out 4 in what we call algebraic simplification to obtain 4 into t minus r as our most simplified form of that algebraic expression. And this one we can now write as 4 into t minus r from the explanation we have given. And that is how we have simplified that particular algebraic expression. Let's look at an application of algebraic expressions. The length and width of a rectangle are L and W respectively. So we sketch the rectangle, name it A, B, C, and D. So once we sketch it, we know that perimeter is distance round the object, total distance around the object. So when we start from A, we move towards B up to point B, that is L. We move from B to C, that is W. We move from C to D, that is another L. Then from D we go back to A, that is another W. So you can see how we are moving. We are moving from A to B, B to C, C to D, and then D to A, back. So that will be perimeter. Now, because we have been asked to express perimeter P in terms of L and W, we therefore say that perimeter P will be equal to A to B is L plus B to C, which is our W. C to D is another L. Then D to A is W. So you can see we have already found our perimeter because we've added distance all around the figure. And because these are algebraic expressions, we collect terms that contain the same pronumeral. So we have L and L, we have W and W, so we put them together. So this will be P is equal to L plus L plus W plus W. So let's follow the same procedure to simplify this. We have L plus L, which we can write as 1 plus 1 into L. The coefficient of L here is 1. The coefficient of L there is 1. So we get L plus L is 1 plus 1, then we multiply by L. And 1 plus 1, we get 2L. Similarly, we can use the same procedure to simplify operation in the pronumeral W. We have W plus W is equal to 1 plus 1 multiplied by W. 1 plus 1 is 2. So we get this one as 2W. So you can now finally see that L plus L is 2L and W plus W is 2W. So we obtain perimeter as 2L plus 2W. That is the perimeter of that figure. But remember, we have said that if the coefficients are also similar, we are allowed to filter it out. And because this is 2L plus 2W, we can filter 2 out and write it as L plus W. So our perimeter becomes 2 into L plus W. That is the most simplified form. So this implies that perimeter P is equal to 2 into L plus W. That is our perimeter. That is now application of algebraic expressions we have been learning and its simplification. Let's look at another example. So we have this figure here, of which we have been asked to find its perimeter. Now, this mathematical operation signs means that AB, BC, CD, and DA are equal. But if you look at the top part, it is semicircular in nature, and therefore we are able to calculate the curved length of the semicircular nature using the formula for finding the circumference of a circle. So we start by saying that 1, the circumference of a circle is pi d. It's pi d. But here, our diameter is equivalent to x. So we say, but our diameter is equal to x, and therefore where there's diameter, we substitute with the x. Remember yesterday we did what we call substitution, and we say that substitution just means replacement. To replace with. So where I have my d, I is replaced with the x. So I get my circumference of the circle as pi x. Since the top part is semicircular, then the arc length now becomes pi x over 2. So we have found the top part as pi x all over 2. That is from C round to D when we move like that. Now, let's now find the perimeter of the figure. We move from A to B, B to C, C to D, and then D to A. So our perimeter P will now be equal to A to B is x, B to C is x, C to D then D to A. So you can see we have covered the distance around the figure using the information we have been given. And because we have similar terms in this particular algebraic expression, remember we have said we group all the terms with the same pronumeral together. So that will give us that is what we have. Now this pi makes the last term not to be similar to the first three. So it will be treated independently. Now what we do, we have x plus x plus x, which we can write as 1 plus 1 plus 1, then we multiply by x. 1 plus 1 plus 1 plus 1 is 3. So this part simplifies to be 3x. So the whole of this part is 3x. So we obtain 3x plus pi x over 2. We can leave it like that, but we are advised always to simplify as much as possible. So we can express under a common LCM that expression, so that the LCM of 2 and 1 is 2. We write 2 there. Then 1 multiplies 2 times, so it will be 2. 1 divides to 2 times, so it will be 2 times 3x. So we multiply this one by this part, which is 3x. We multiply it by 2 over 1, which gives us 2 times 3, you get 6x. Then here we have 2 into pi x over 2, which will we divide by 2, we get 1, divide by 2, we get 1. So that gives us pi x. So we have 6x plus pi x. But we remember we have been told that if we have the same pronumeral, we can write this one as 6 plus pi in bracket x all over 2. So we filter out x, so we remain with 6 plus pi into x all over 2. That is the simplification of that particular algebraic expression. So we can say, therefore, perimeter P is equal to 6 plus pi into x all over 2. And we can be asked in questions, application questions, that show that perimeter P of the object is given by 6 plus pi into x all over 2. We can be told to show that. So we use the procedure of getting the perimeter using the pronumeral that has been defined to simplify our algebraic expression. This marks the end of our lesson for today. Thank you so much.